Hello, my name is Aaron Rostad,
My name is Shaker Sharma.
And I'm Neil Uroy.
and we're doing fixture tracking and storage redesign at Scientific Drilling in fulfillment of our Cal Poly IME senior project. Today, we will start out with a refresher on the current problem at Scientific Drilling, followed by an in-depth explanation of all of our deliverables, and finally conclude with the future impact this project will have for Scientific Drilling.
Scientific Drilling is an international and independent directional drilling and wellbore navigation company that mines for oil and gas. The company is founded in Houston, Texas in 1969 and has grown rapidly over the years, serving customers worldwide. Their global footprint has reached over a dozen countries and in nearly 50 locations, with their Applied Technology Center based in Paso Robles. This is where most of their research, development and manufacturing is done, and over 20% of their total global workforce is on this campus. Currently, Scientific Drilling's workers are dealing with daily distractions due to a lack of formal process in storing and tracking their fixtures as well as their test equipment. Right now, there is no way of finding out where a certain fixture is without blindly searching in areas that it usually shows up in or by asking the surrounding employees. Many times, this leads to a wild goose chase of who used it last. These distractions take away time from workers on the line as well as engineers when they are interrupted by workers looking for equipment.
Scientific Drilling and our team have decided on the following deliverables: an implementation plan for them that includes a design for the new tool crib and a plan to transfer all the tools from the old locations to the new locations, an analysis of RFID versus barcoding, a self-checkout system made on Microsoft Access to assist workers in finding tools and assist management in keeping track of their assets. In order to make sure that all of the processes are standardized and sustained, SOPs will be in the database and on Word document. This will ensure a smooth transition to the new system with minimal hiccups. Upon the first plant arrival at Scientific Drilling at the beginning of last quarter, a safety video was shown which emphasized a company culture that cares for its employees' physical and mental well-being. Taking all ergonomic standards into consideration, the layout of the tool crib is designed to have heavier tool fixtures and large bins on the bottom shelf of the middle main rack, medium-sized bins on the next shelf up, and a smaller-sized bin on the top shelf being used. By comparing the total footprint of bins in square inches of the current available space and dividing that by the proposed layout of bin space plus additional tolerances, about 48% of the space available should be filled with tool fixtures, leaving 52% for newer added tools. This does not include the tool fixtures that remain at the employee workstations on the manufacturing assembly lines. A total of 24 small bins, 24 medium, and 9 large bins fill up the main middle rack. And since the cost of these bins are minimal, an additional 12 small, 12 medium, and 9 large bins can be added to the rack on the back wall for additional spacing. Each bin will be organized and labeled accordingly from left to right of each shelf, starting with the middle main rack, which makes it easy for employees to locate the correct bins and not misplace any items from their designated location.
Within the scope of this senior project, Scientific Drilling included an analysis of using RFID versus barcode. We used an AHP, or Analytical Hierarchy process, to support our decision between the two alternatives. A set of 5 different criteria factors were used to come up with an optimal solution. From these weighted factors, we were able to conclude that barcoding is the optimal solution for the Scientific Drilling's current state. RFID has many benefits, however, since Scientific Drilling doesn't have a tool crib checkout system in place, barcoding is the best process to first implement as a prototype. QR codes were chosen due to their compact design and feasibility. Each QR code contains a unique 3-part structure. The first part indicates which tool crib within the facility the tool belongs to. This is going to be letters A through Z, and like A would indicate tool crib A. The second part is the unique tool type, whether that be a crimper or a soldering iron. And the third part is 4 digits, and it is the unique tool type. So crimper number 1, soldering iron number 4. Now, Shaker is going to explain how these QR codes get stored into a database.
The self-checkout system was completed using Microsoft Access with the majority of queries in SQL. This will make it easier for Scientific Drilling to import all of the queries into their own database system over the next few years, and it will increase the scalability of the project. Workers on the line will be able to query tools by name, ID, or part number for checkout, and the database will give the workers the location and status of the tool in order to find it quickly and efficiently. Managers and team leads will be given access to the password-protected cycle count page where issues with incorrect data can be resolved. They will also be given access to the new tool page where managers can add tools after purchasing. A history table was created in order to provide more accountability and for managers to see the trends of tool wear and malfunction. The system will also provide further metrics for the managers that can be analyzed to further improve efficiency.
Since all tool fixtures will be barcode tracked via database, workers will no longer have to waste their time or their peers' time looking for these tool fixtures, which will save the company money and should decrease the lead time for making their wellbores. Management will be able to get better performance metrics on their tools. Based on these metrics, the tool crib can be continuously improved during cycle counts. As more data is collected, the tools that are used the most will be moved to the most ergonomic locations. Managers can also base their purchases on previous reliability from each company. Since the main middle rack can be accessed from both sides and the bins containing the tool fixtures are clearly organized, the ergonomics will be significantly better than reaching far into a cabinet or looking vigorously for a misplaced fixture. This new implementation plan is designed to be scalable and repeatable to any other tool crib location on Scientific Drilling's campus.
This was our senior product presentation. I hope you enjoyed it. If you have any questions, please contact Aaron Rostad at the email shown.